go. Learn OS++. It's a framework. It runs on OpenSCAD. You need OpenSCAD installed on your PC for it to work. In this particular course, part one of it anyway, we're going to go from this cuboid, which is an OS standard cuboid, to this. Let's get on. All right. So if you've installed OS standard or OpenSCAD properly, you should now have the following screen. So you have a place where you've got code, which is here, place where you can see a model, which is here, and a place where you've got the console, which is here. If I click on this area and hit F5, we get a cuboid. Very, very exciting. Right, this is quite exciting because what it means is that I can output code from, let's say, C or Bash, print out this particular statement using variables from C or Bash, and then use OpenSCAD to generate a real-life object from my actual C code, which is pretty cool. I've done that a couple of times, and sometimes the results are very different from what I was expecting, but correct. Anyway, we haven't installed OS++ yet, the framework. What I wanted to do was I wanted to show some of the features and names of this particular cuboid such that you know what I'm talking about later on. So we have the cube. Very, very exciting. X has 11 units, Y has 21 units, and Z has 31 units. If I change these numbers, the cuboid will change too. Press F5, shrinks a little bit. I want to talk about the cuboid in all of its glory, and the very first thing I'd like to point out is this. Pressing F5, this is 0.000. I have highlighted it using a red sphere. I have translated plus X of 0, plus Y of 0, plus Z of 0. So I haven't moved at all. I'm going to call this corner from now on 0, 0, 0. All well and good. The next point I would like to point out is this. The blue sphere, let's make it a sphere. The blue sphere is at 10, 0, 0. I've called this L00. And what I mean here is that X is the last point of the cuboid, Y is still at 0, and Z is still at 0. So 0, 0, 0, L00. Now using this naming convention, you can choose any of these points. So for example, if I said LLL, that would be the last point. The x-axis would be in the last point of the cube. The y would be at the last point, and the z would be at the last point. There you go, all very nice. Let's just add a couple more just for fun. Okay, so what we have here is we have spheres or balls on the end of each corner, and I've just tagged them with this name. All well and good, awesome. The problem comes when I change the cuboid. All of a sudden, my balls are not on the end of my corners. This is a problem because what this means is I have to actually go through manually and change the translate statements such that they're now in the correct point. This is quite frustrating. As you can imagine, it's time consuming. Okay. You'll notice that point or the corner 0, 0 didn't have to change. It was fixed. I'm going to call this an anchor point. And what I mean by that is it's the point that a cube will grow from. It's the only point which is fixed. So I can choose any numbers here and this will always be in the same place. All the other corners keep moving. So wouldn't it be great if I could create a cube from any corner? So first of all, rather than specifying this corner, let's specify this corner. Wouldn't it be great if I could call these particular corners in my code such that this statement is not required? And what I mean by that is, so every time I change the cube, these will automatically change for me because I specified these corners rather than an absolute translate. That's basically my wish list to begin with. And what we're going to do is we're going to see how that works with OS++. Okay, so the next thing is we're going to install OS++. OS++, let's install it. What you need to do is open your browser and go to this website which is osplus.org. Once you're there, you click on this download icon, or alternatively, you can click on this HTML link. If you save as, you should get a file. This file is called the download. To extract it, what I do is I'm going to right click and open it up with my archive manager. This is the default archive manager I have. I'm going to click extract, hit extract again, and close my archiver. Now what's happened here is I've now generated two files, file number 1, file number 2, or folder number 1 and file. Both of these files can be reproduced from this archive. Now this file is the welcome message, and because I'm miserable, I'm going to delete it. And I'm going to rename this to my project. So if I wanted to reproduce those two files, I simply go back into the archiver and regenerate them. So this is the framework. These files, all of these files, are user files. They're there to make your life easier, to give you examples, and to basically tell you what's going on. The actual framework itself is here. It's in z_lib. So what this means is I can delete all of these files and start again with my own project. Since I want to do some examples, I'm going to not delete learn hard A, which basically is a list of examples. I'm not going to delete template minimal, which is basically the minimal template to actually get OS++ running. And I'm not going to delete lucky dice. Everything else, gone. Okay. So in summary, what do I have here? I have the OS++ framework in z_lib. I've got an example of a lucky dice. I've got learn hard, which is basically a list of examples, and I've got a template. So I've already got OS standard installed. So what I'm going to do is I'm going to open it up with my OpenSCAD. All right. I have now opened up a list of examples. Let's quickly go over what's going on here. The following declaration is standard on all OS++ code. Effectively, this is the important bit. The first part tells us that we're running OS++ code. The second part tells us what standard we're running. And the third part tells us the user grade. Now, currently this is amateur, which basically means that it's not standard. There's two basic standards. You've got professional, which is a proper standard, and amateur, which says I'm just going to have fun. Don't judge me. All of these, this is a web page, which can give you all the notes about all the front door for the website. This is a web page, which documents the standard itself. And this is a web page as well. And that'll take you through what amateur means and the other different user grades. You also got this little HTML, web link, which is basically takes you to docos. This is more of a PDF, a set of PDFs to show you what's going on. I prefer doing the by example because then you can see exactly what's going on and you can play with it as you go along. Basically, we go over, there's a whole bunch of example instructions, which I'm not going to go through now. I'm going to go straight to our example. So, module main, and here's our example. Now, if I press F5, absolutely nothing's going to happen. And the reason nothing's going to happen is because everything's remmed out. So when I want to get rid of a model, rem everything out, press F5, it all disappears. Right, so how do I actually get this example going? Well, you'll notice that this particular piece of code is remmed out. So if I rem out the rem block, which is by doing this, I should now run this code, which is a lot of rems and one tiny statement. Now this statement is a replacement for cube. So rather than using OS standard cube, we're going to run libcuboid. Libcuboid is the main module for libcuboid. Anything that starts libcuboid is in the libcuboid library. The next part of the module is our anchor point. That tells us how it's going to generate the cube. And the last part of the statement is the cuboid itself. So if I press F5, we get a cuboid. Very exciting. Basically what we recognize. So, in a previous part of the course, I explained that this corner here is called 000. This corner here is called L00. And all that L00 is the last point of X followed by 0Y and 0Z. This here, this corner, is LLL. LLL simply means the last corner of X, the last corner of Y, and the last corner of Z. So if I change this to LLL, I'm going to reprint this cuboid using this corner. So the translate is here, and we're going to print this corner, this cube. So if I hit F5, ta-da! So this is exactly the same cube. It's exactly 10, 20, 30 as before. But now, rather than printing it from the bottom leftmost, frontmost corner, I'm now printing it or rendering it from the topmost, rightmost, backmost corner. And as a result, the whole cuboid itself is in a different quadrant. What this means is that I can build up a shape and not even use a translate because it's all part of one shape. I think that's pretty cool personally. Right, well that's example 1 done. So what I'm going to do is unrem my rem, so it's now remmed out, and press F5. And as you can see, the cuboid has disappeared. Excellent. Okay, let's do example 2. Right. We move down our list of examples. We should be at the next example. Here we go. OpenSCAD versus OS++. All right. What we have here is a variable declaration. So we are saying that the variable standard underscore cube is going to have this data type, which looks remarkably like a cuboid. The following code is unremmed. So we have cube, standard cube, which will give us a cuboid. Then we're going to move 0, 0, 0, which is not a move at all. And then we're going to render a sphere at that particular point. So let's do that. Let's rem out our block rem at the top, rem out our block rem at the bottom, and hit F5. There we go. There is our standard OS standard cube with a sphere right at the bottom. Right. Now I'm going to give you exactly the same code, but for OS++. F5, and nothing happens because it's exactly the same. Let's have a quick look, squiz at this. libcuboid, we've come across this one before. Basically, libcuboid is a module that lives in libcuboid, and it's the main module. We're going to render a cuboid from corner 0, 0, 0, and we're going to use the variable standard cube, which is from up here. Then we're going to translate or move, and then we've got this horrible function here. So let's break down this horrible function. Lib underscore cuboid, well, we know that it's actually going to be in the libcuboid library. Lib underscore cuboid underscore mv, well, that's short for move. And what we're going to do is we're going to move from corner 0, 0, 0 to corner 0, 0, 0 with regards to the standard cube. Now, if I move from here to here, it doesn't matter what the standard cube is, we're not going to move at all. So effectively, we have generated this command. Then we run the rest of the command of OS standard, and that's the example. Right, what I'm going to do now is I'm going to take this code, F5 to get rid of it. I'm going to take this code and I'm going to put it into here. So I'm going to call this my project, my model. Okay. Open with OpenSCAD. And here is the template. Right. First of all, we have the standard declaration, which we've already discussed. And basically, I'm telling everyone that I'm going to write to the OS++ standard using a professional grade. I am going to keep to the standard. Don't really need this. Don't need that. Don't need that. Don't need that. All right, what's this? This command, this is the command that calls the OS++ library. As you can see, it goes into z_lib, which is a subdirectory. It then calls this file, which is the SCAD file, and all this does is it calls a set version of cuboids, a set version of spheres, and a set version of cones, which are cylinders. And because it always runs this particular file, it will always bring up that version of the code, which means that even if I upgrade to the latest and greatest OS framework, it will always run the old modules because I've told it to run the old modules. Effectively, what I've done is I've made these modules canon. Anyway, basically what it means is as long as that statement's in there, it should work, even if I run the latest and greatest OS++. Even if I'm using a bug in the code and I've since corrected the bug, it will still work because the bug will still be in the old code. What is he going on about? I don't know. Right, the next bit of the code tells us to run the module main, and I'm going to put my code in here. Okay. So I hit F5. There we go. Now I just want to copy and paste from the console. And what I'm going to do is I'm going to pop this here. So I'm going to put it into a block. And the only reason I'm putting it in here is so that you can see it. Okay. So when I ran this command, it printed a hello statement to say, hello, I'm running. You are running this include. So this include, it's actually said, look, you are running this. As soon as I run this piece of code, it will load up this version of the library. So when I run libcuboid that I'm running from will be from this library. If I had libcone, it would come from this library and it would be a cone. And if I was running libsphere, it will be in this library and it would be a sphere. If I wanted to get some help, there's some help available, so on and so forth. All right. Shall I leave that up there? I'll leave that up there. There you go. All right. So here's my code. Isn't it exciting? Let's remove the superfluous OS standard code. What I want to do, I'm going to put that variable up here. I call this global space. What have I done? I have put standard cube into global variables. What this means is all of the modules from now on will have access to standard cube. Why would I need to do that? Well, what OS++ gives me is the ability to move around the cube. So this command renders, this command renders my standard cube, and this command moves around that standard cube. Doesn't move very much, but what I could do is say, right, oopsie. Yes. All right. So what I'm saying is I want this libcuboid saying I want the translate from 000 to L00, which gives me that point there. And I can do this again if I wanted to. Can I copy and paste? Okay, what have I done? Okay. So what have I done? I'm rendering a cube from 000, which is that point there. I then translate from 00 to 00 with regards to the standard cube, which means I'm still there, and I print a colored sphere. I then do another translate from 000 to L00, which is this corner here, with regards to standard cube, and I print a sphere. I rinse and repeat. Basically, these are exactly the same commands. Maybe I should do it that way. Now what this means is if I do change my cuboid or tweak it, all the points are in the same place. It's automatically calculated it because I've specified that I want to move from 0, 0, 0 to 0, 0, 0. It works out the translate for me. So I can put any number in here I like. I can do any sort of tweaking and it simply recalculates. Let's go back to the original. Okay, so what happens here? 5. So what happens if I go to regenerate my cuboid using LLLI, this point here? Okay, so my points are still where they should be, but I've now rendered the cuboid in a different way. I'm using this particular corner to render it rather than the standard 0, 0, 0. So I've now changed the anchor point. Right, okay, well, if I wanted to keep it all together, as it were, maybe I should put another variable in. I'm going to use anchor. And all I'm going to do find and replace. Replace all. Hit F5. Oopsie. What have I done wrong? Unable to convert parameter to vector 1 and 2. Good God. I'm going to have to redo this. Error invalid anchor. What have I done? Let's quickly rem this all out. Switch back one. Ah. Right. Yes, of course. Oopsie. Sorry about that. Okay, what I've done incorrectly was I'd put the word anchor in quotes and it tried to interpret anchor as an anchor. Okay. Production is starting again. Right. So now if I change to using that, all my points move with me. Now notice that this is still 0, 0, 0, even though it's not at 0, 0, 0. From the point of view of the cuboid, this is still 0, 0, 0. This is still L, L, L. This is still L, 0, 0. This is still 0, 0, L. It doesn't care. As far as the cuboid is concerned, it's just simply rendering it from a different anchor point. All the reference points have now changed. Right. Now what I'd like to do is I'd like to show you that we can actually take this particular, any one of these translates, and actually change it out for an echo. Okay. So all I'm doing is I'm taking from the console the echo command so that you can see it. So you can see that this command lib cuboid mv has been turned into that data type, which can be used by the translate. So there's nothing magic going on here. It's just a straightforward function. Right, I know what you're thinking. You're thinking, well, you know, Stephen, 8 corners, that's not many points, is it really? Well, yeah, you're right. Let's go back to 0, 0, 0 because it just makes life simpler. So we have 0, 0, 0. We have L, 0, 0. So X is 0 here, X is L here. What about the middle? What would we call that? I don't know. Let's call it middle. So I'm going to rem this all out. Use this another time. And I'm going to take my little blue sphere. And I am going to say M. M for middle. So what I'm saying here is I want to go from, I'm going to do a translate. I want to use a cuboid move. I want to go from anchor, whatever that is, to this point here, which is the middle of X, the beginning of Y, and the beginning of Z. Hit F5. Ta-da! The blue ball is now in the middle between those two. So if I change this to 15, it's still in the middle. Now, the more mathematically inclined of you will know that if X can be either 0, M, or L, there's 3 possibilities for the X, 3 possibilities for the Y, and 3 possibilities for the Z. 3 times 3 times 3 is 27 possibilities. So this cube now has 27 points that I can access straight off the bat. So if I say difference, which basically will remove my sphere, I now have a little blue hole in my cuboid. But I don't want a cuboid. I want a cube. Okay, fair enough. Looks a bit pointy to me. Looks a bit pointy. So what I'm going to do is going to add a little bit more information. Comma 4 simply means I want this to be not a cuboid, but I want it to be a rounded cuboid. And 4 simply means that the spheres on the corner will have a rounded diameter of 4. If I hit F5, I now have a rounded object with a single spot being taken out. Let's make that spot a bit bigger. Let's go with 5. There you go. Let's make this a little bit bigger. Let's go for 50. There you go. It's beginning to look a bit like a dice, or a die, I should say. Right, and I think that's enough for this particular part. What we'll do now is go through an example of the dice. Let's just do it. So here we've got an example of a lucky die succinct version 2. Let's open it up with OpenSCAD. What do we have? So we have a declaration telling us that we're writing this in OS++ professional standard. Tells us what we've got, and there's some general information which I added to these things. Then it talks about loading up. That's not right. Don't worry about that. I'll have to remove that later. Okay. Tells us that we're loading up this particular version of OS++. Okay. This particular area is my global shapes, which I have talked about before. Basically, all of these variables are now available to all the modules. What I've done is I've said this is a cuboid. This is the body of the cuboid. Here we have the cuboid itself, which is actually a cube. It's going to be 20, 20, 20 with rounded corners of 4. We're going to be using a sphere. So the standard declaration is sphere underscore and then a description. That's going to be sphere dot, which is going to be 4. And then we have another sphere, which I'm going to be using later on. Okay. Got a little area which tells us that we're going to set the anchor body to whatever. Don't worry about this, but it's basically the same as we've got before. And then we've got a rotation. This rotation is purely for 3D printing. Very often I will design something which hasn't got a cat's chance in hell of 3D printing, and I need to rotate it so that the bottom is always flat so I can actually 3D print it. So what I can do is I can design it one way without any worry about the 3D printer, and then rotate it automatically for you, and that's simply what we're doing here. There should be a variable back up here. Here you go. I haven't bothered with that because we're not going to 3D print it. Okay, so now we're going to go into main. And in the same way as we were deleting a single object, you can see that we have face 1 dot. First of all, we render the cuboid from that anchor with that body. Now we're going to remove 1 dot. We need to move to the middle of X. Y remains the same, it's going to be the front face, and then Z is in the middle as well, using the cuboid body, and we're going to do a lib sphere. Now, lib sphere, we know straight away that lib sphere comes from the library lib sphere, and it's basically got this function called rgrid. Now, the face 2 is exactly the same, and then we've got different numbers. All this is it's a third of 3/10 of the way along, 3/10 of the way along, and 0 way along. And you can actually match them. You don't really need to know this. We'll discuss this later. But basically, all you need to know is that this is a move. And so is this. And basically, what we're doing is we're moving to different areas of the cube using different reference points. Now, you're going to be looking at this going, what the hell is that? Don't worry, we will discuss this later. But just understand that not only do you have base 3, which is 0, middle, and last, or 0, M, and L, you've also got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, L. And what that stands for is 0 is 0, obviously. 1 is 1/10 of the way along. 2 is 2/10 of the way along, up to 9/10 of the way on, and then you've got L, the last bit. Because very often I'm going to want half a space, or a third of a space, or a quarter of a space along the line, I actually use base 12 as well. Now, base 12 uses the letters A, B, C, D, E, F, G, H, I, J, K, L. L, A is 1/12 of the way along, B is 2/12 of the way along, C is 3/12 of the way along. Now, C, 3 divided by 12 is a quarter. D is 4/12 of the way along, or a third. F is 6/12 of the way along, or a half. So the number 5, M, and F all mean half or midway. Don't worry, we're going to talk about this later, but basically we just simply move around the cuboid using these particular translate statements. What this means is if I really want to, I can actually change the body and all of the spots will recalculate because they're all proportional. There you go. It's a bit silly, so let's go back to 2. 5. What else can I say about this? Ah, yes. Because these variables are in global, it means that all of these modules have access to those variables. Now, what this means is if I wanted to, I could take that get 5 to prove that I'm actually running that code. Let's hit 5 again. So what am I doing here? What's happened? What am I trying to explain? What I've done is I've created another module, 2, which is up here. Because this variable here is in global, it means I don't have to redefine it for every module. And as a result, any module can roam around this particular object. So even though I might not render an object in a specific module, I might need to translate or move through that object to get from, let's say, this point to this point, whatever that point is. And that, of course, can change. So the moment we're in so everything is being regenerated. All the numbers are being regenerated, and you just don't have to worry about it. And that is that. Let's give it a bit more. Go to 50. There you go. So that's our cube, and that's our example. I think it's quiz time because I've had enough. Excellent. Let's stop that. Quiz time. Let's do some quizzes. Question number 1. A shape's anchor point is A, a point where a shape grows from as we increase its size. B, a fixed point on the shape no matter what size it is. C, a point where a shape shrinks to as we decrease its size. D, the same point as the translate point. E, all of the above. What is your answer? Question 2. Which corner of a cuboid is the rightmost, frontmost, topmost cuboid's corner? A, this isn't an exact description of a corner and so does not have a name. B, lol, I have no idea what you're asking for. C, point x equals 10, y equals 0, z equals 50. D, point equals 10, y equals 0, z equals 15 of a cuboid equals 10, 20, 30. What is your answer? Question 3. You encounter a function called libcone_mvrgrid bracket bracket. Where is this code stored in the OS++ framework so you can inspect it? A, we have not discussed libcone in detail yet, so I don't really know. B, it will be stored in the z_lib subdirectory along with the rest of the framework. C. The library's file name is something like libcone_v*.scad. D. The console will list all the libraries. When you render the model, it's one of those. E. All of the above. Right. What is your answer? Okay. Now, if you still want some more time, stop the video now because I'm just about to give you the answers. So let's go back to the top. A shaped anchor point is a point where a shape grows from as we increase its size. A fixed point on the shape, no matter what size it is. A point where a shape shrinks to as we decrease its size. D, the same point as the translate point. E, all of the above. Right, what I'm going to do is I'm going to go into my project, and all of a sudden we have Q1 SCAD. Okay, so here we have our OS++ program. We've got a translate statement up here. We've got a libcuboid here, which will create a cuboid using 0, 0, 0 as its render point. And very helpfully, we've got a red sphere, which is growing from its middle, and it's got a size of 1. It's here 5. Okay, right. So what was the question again? A point where a shape grows from as we increase its size. All right. So our anchor point is 0, 0, 0 for libcuboid. And what we're going to do is we're going to increase its size. Hit a 5. And as you can see, as it grows, that point has not moved. A fixed point on the shape, no matter what size it is. Well, that's true as well. A point where a shape shrinks to as we decrease its size. All right. Let's pump in 5, 15, 20. Yep, it shrunk and it shrunk to that point, and it's still a fixed point. The same point as the translate point. What's the translate point? Let's have a look. Well, we've got translate here, so let's give it 20, 10, 20. So that's my new translate point. Oh, it's flipped over. So yeah, it is my translate point. There you go. If I move my anchor point to, I don't know. My anchor point is still there. So it is making the translate. In fact, if I was to say 5, 15 and 20, we've got a cuboid, which is being rendered from LLL, and therefore its anchor point is here. And it's giving us the same shape as if we'd rendered it from here. So anyway, the point of it is that the anchor point is the same as the translate point. So the answer is E, all of the above. Which corner of a cuboid is the rightmost, frontmost, topmost cuboid's corner? Oh my God. Right. No, that didn't work very well, did it? Okay. So we have a cuboid example. We render that example using an anchor point of 0, 0, 0. We're now going to move from 0, 0, 0 to something else using the cuboid example. And then we're going to pop a red sphere bang in the middle. Okay. So we wanted the rightmost. Well, I pump that in. Let's move to the right. So this is the rightmost. Frontmost, so we want it in the front. So it's going to be, Y is going to be 0, because because that's the front, and topmost. As you can see, it's LOL. So this would be the example. This would be my correct there. This would be my answer. LOL. I have no idea what you're asking. Maybe a little bit of a tricky question, tricky answer, but there you go. You encounter a function called libcone_mv_rgrid. Where is this cone stored in the OS++ framework so you can inspect it? A, we have not discussed libcone in detail yet, so I don't really know. Well, that is actually a true statement. We haven't discussed libcone yet. It will be stored in the zlib subdirectory along with the rest of the framework. Well, let's have a look. Go into the zlib subdirectory, and I have a file called lib_code_v something.scad. So that looks like a true statement. The library's file name is something like libconv_star.scad. Well, we've just proved that works. The console will list all the libraries when you render the model. It's in one of those. Okay. Well, if you look at our console, you can see it's loading up a cone. So that would be a true statement as well. So in summary, E, all of the above. All right, that's it. I hope you've enjoyed the talk. Now we've got part 2 where we could do example 3. It's going to be very exciting. That will follow shortly. Thank you.